we're going to try and make this as complicated as possible. We're going to be thinking about what we have to do to make a solution concentration. So alteration, or this, and then we have to figure out everything else about it, how much solute's needed, all that stuff, and it all do basically two equations. First, you already know that the percent by mass or volume, either one, equal to the either mass or volume of the solute over the mass or volume of the solution times 100. And then the other part of that, the solution is equal to whatever amount of solvent plus solute. Now, notice that that necessarily, strictly speaking, have to be true of, but it will be in all of the cases that we look at. And so between these two equations, everything I'm about to ask you to do can be done with these two, but it requires thought. There's not a formulaic way to do it. You simply must think about the problem and show your work. So let's look at an example, and I'll leave these two on screen. Suppose I want a solution, and we'll say that is 80% by mass alcohol. And we're going to, unless it's otherwise said, you can assume that things are dissolved in water typically. If it's a solvent other than water, usually it'll get said. Suppose I want a solution that is 80% by mass alcohol. If I want 500 grams of solution, how much salt do I need? And forgive the long writing. How much solute is needed? Now again, these two equations up here are pretty much all you need. So in this case, stop and think about what I want. I want how much solute we have, and I know the percent by mass, so I can say that 80 is equal to whatever my mass of solute is, and I'll write M sub S. We've got lots of S's in here, so I'll just finish that out. Solute divided by the mass of the solution times 100. And now all it is a simple math problem in order to solve for that. So first thing I have to do, I've multiplied by 100, so I divide by 100. 0.8 equals the mass of the solute over 500. And now I just have to multiply 500 times 0.8. And unless I'm mistaken, we should end up with that. And that's 400 grams in this case. So again, notice how it's just using these two equations. We didn't even need the second one for that. And we get that. Now, let's ask a related question. Given the same situation, how much solvent is needed? So we know in this situation that I need 400 grams of solute, but how much solvent do I need? Well, this is where our second equation comes in handy. The amount of solution is the amount of solvent plus the amount of solute. So if I just write that out, equals solvent plus solute, replace what I know. I know I have 500 grams of solution. I don't know how much solvent I have, or how much I need rather, but I know I have 400 grams there. Subtract, and we find that I need 100 grams of solvent, just like that. Now notice where this gets cool, and think about this in a physical situation, is that I now know exactly how much stuff I need. If I want to physically create this solution, my cabinet and get 400 grams of alcohol, mix it with 100 grams of water, and I have an 80% solution of alcohol. All right, now we're going to look at a slightly related problem. Again, it's always going to be these two equations that you're using to solve any of these problems. So let's look at this situation. We've got 50 grams of 40% by mass solution of salt in water. How much solvent, that is water, should be added to make the concentration 5% by mass? This process is called a dilution. We're adding more solvent to reduce the concentration of our solution. And let's start setting this up. We know we want a solution that's going to be 5% by mass. So 5 has to equal the mass of the solute over the mass of the solution times 100. And so we have obviously missing information here. We either need to know the mass of the solute or the mass of the solution. So let's stop and think about where all the solute's coming from. Where is my salt coming from in this situation? If I'm adding solvent, I'm just adding pure water, so I'm not adding any salt. So all of the salt has to come from my 50 grams of 40% by mass solution. So I have to start another problem here where I say I have 40% by mass and the mass of my solute divided by, well, we know how many, or what the mass of solution was. It was 50 grams, and I'm multiplying that by 100. So now I can do a little math here. I know that 0.40 is going to equal the mass of the solute divided by 50. And now all I have to do is go through and multiply that. So 50 times 0.4 is 20. So I know I have 20 grams as the mass of solute. So there I've figured out part of my problem. I can now substitute this back in. I'm just drawing that arrow for your edification. You don't necessarily have to draw that out if you were working this problem. But now I know the mass of the solute. What I can do with this is now I can go back to my original equation and I can figure out how much solution we need. So I'm going to work this on the side here. Note that this can get very messy very fast. So I know the mass of solute is 20. I don't know what the mass of solution I need is. Times 100. And just as before, we go through and solve this. And we end up with this situation. If you're having trouble with the math, let me know. We can go through and work it together. We're going to multiply now both sides by the mass of the solution, then divide by this 0.05. And we find that we should get 400 grams of solution. So we know that in this final situation, once we get to the point where we have a concentration of 5% by mass, we're going to have 400 grams of solution. But that's not what the question is asking. The question is asking how much solvent should be added. So we need to know how much solvent there was to begin with. So we go back to this situation right here. We know that in 50 grams of our original solution, there were 20 grams of solute. Well, if there were 20 grams of solute, we can use the other equation that the amount of solution is the amount of solvent plus solute. And if there were 50 grams of solution, and we don't know how many grams of solvent, but there were 20 grams of solute, you can probably see that we started with, you guessed it, 30 grams of solvent. So now we have to take all of this, combine it together with this. Notice this is the mass of the solution, not the mass of the solvent. You have to be very careful there. Well, how much solvent do we have? We use the same equation again. And if we have 20 grams of solute, we must have, in this case, 380 grams of solvent. And now we can use these two facts. We started with 30 and we're going to end up with 380. That means the total change was 350 grams. So we had to add 350 grams of H2O in order to make this solution. All right, notice that this is complicated. This requires a lot of steps and it requires a lot of thought. There's no way around that. You do have to think, you do have to use these steps and calculations. Things will probably get messy. I actually highly recommend that one of the things you do is have a scratch sheet of paper where you work out these problems the first time and then go back and make them pretty later. For example, this I wouldn't necessarily want to turn in. All the steps are there, but it's pretty unclear what order I did them in, things like that. I would want to go back and rewrite this in a more organized way, and I don't have any particular setup that I'm going to require you as far as organization of those, just that you be able to, if I can't figure it out for myself, that you can quickly explain it to me. Given all that, you will see other types of problems besides this one, but all of them come back to this same idea. You have these two equations, and you have that wonderful couple inches between your ears, and combining those, you should be able to solve any of these problems.